Assalamu alaikum student. Today we are going to start our new chapter, that is the turning effect of force. Now this is the most common example of turning effect of force, that is seesaw. Now let's see what uh, we are going to discuss first in this segment. In the first we are going to discuss moment of force and the moment of force. Describe moment of force or talk as a moment of force into perpendicular distance from pivot to the line of action of force. So there are many things we are going to discuss. Moment of force or torque, they are same thing. What is momentum? What is line of action of force? And we are going to explain the turning effect of force by relating it to everyday life. So what first is that what is torque or moment of force? These are the words we interchangeably use for our use. Now to explain torque or moment of force, let us see this figure. In this figure, you can see that this is the force F1 acting and the same magnitude F force 2 is acting in the downward direction. These are the two unlike parallel forces. The algebraic sum of these two will be 0 because they are acting in the opposite direction. So we see that the body is in translational equilibrium, but again it will rotate. It will not remain in this straight condition, although it is in equilibrium, but will start rotating from it. This is your clockwise. It is rotate clockwise. Now, uh, this since the body is rotating, this turning effect produced by the force is called moment of force or torque. Or this is the symbol that we use for writing mathematical expression. We use this symbol for moment of force or torque. Now we are going to discuss what is torque or moment of force. Torque is a mere of force that can cause an object to rotate about its axis. Just like the door handles, you rotate a door handle on the axis, you rotate the door on the hinges. That is this force that is called the torque. Uh, just as the force cause an object to accelerate in linear kinematics, but in torque, the torque cause the object to causes an angular acceleration in the body. Now, in physics, torque is simply the tendency of a force to turn or twist. As you can see that different terminologies are used. So the proper definition of the torque is the turning effect of force about the axis of rotation. This is the hinges are the axis of rotation, and you can in different objects the uh, axis of rotation are different. We are going to uh, see that in different objects. Torque is equal to force multiplied by the momentum. Force applied multiplied the momentum mathematically can be written. This is torque. R into R is the momentum and F is the applied force, and it is denoted by Greek letter, and the SI unit of torque will be a force. The unit of force is Newton, and the unit of momentum is the length, that is your meter, and it is a vector quantity. So the SI unit of torque is Newton meter, and it is a vector quantity. So we are what is the momentum, what is the applied force, what is the line of action of force, we are going to discuss. Now see that torque is equal to R into F, where F is the applied force, R is the momentum. Now the momentum is defined as the distance from axis of rotation to the line of action of force. Now you can see this is the line. We are just uh, turning a wrench. Now you can see that this is the force we are applying on that, and this is the axis of rotation or center of rotation, and the distance between the axis of rotation till the force, that is called your momentum. and sometimes it is also called lever arm. Now you can see that if we extend, this is the line of action of force, that this is the axis of rotation, and this perpendicular distance from line of action of force to the axis of rotation is called moment arm or lever arm. Torque is created when the line of action of force do not passes through the axis of rotation. Now you see that this is the line of action of force, and it is not passing from the axis of rotation. If it passes from the axis of rotation, it means that there is no moment arm and no turning effect. Now what is the line of action? A force is an imaginary line that follows the direction of a force and passes through its point of application. Now you can see this is the point of application. It passes through point of application and it is following the direction of force. So we have learned that uh, moment arm is the perpendicular distance from axis of rotation to the line of action of force, and F is the applied force. The force applied, in this case, the force is applied by hand to turn this, to turn a fasten a nut. Now you can see that in this case, this is force, this is the direction of force. The distance from this point to this point is the moment arm. Now this is the axis of rotation. See that now when we say that the force, this should be a perpendicular distance, the line of action of force, if passing from the axis of rotation, it means there is no moment arm and there is no force. The the max the force is maximum when this moment arm and the force, applied force, are perpendicular to each other. You see that again. Now, in this case, the line of action of force passes through the axis of rotation, so there is no perpendicular distance, so there is no momentum, and there is a decrease. There is a decrease in torque. So the maximum torque, if you want a maximum torque, then the angle between the applied force and the momentum should be perpendicular, should be 90 degrees. The other factors that are affecting the torque, you can see that if the force is increased, torque is increased. If the this moment arm or lever arm is increased, the torque is also increased, because torque is F multiplied by D. If F is increased, torque is increased. If D is increased, torque is increased. Now this is again an animation that's showing you the force. The more is the momentum, the more is the torque produced. If we decrease the momentum, the torque produced will also be less. So the factors affecting the torque are: magnitude of the torque depends on, first is how much force is applied, the length of the momentum that connect axis to the point where the force is applied, and the angle between the force and the momentum. So there are three factors on which the torque depends on. The more is the force applied, the more will be the torque. The more will be the length of the momentum, the more will be the torque. And torque is also affected by the angle between the momentum and the force. Torque will be maximum when the angle between them is uh, will be uh, say uh, 90 degree. If the force vector make an angle of 0 or 180 degree with the axis of rotation, that there no torque will be produced. So value of torque in these two cases will be 0, and it will be maximum when it is 90 degree. Yeah. So the torque is the turning effect of the force. So turning may be, you can see this is a clockwise rotation and this is an anti-clockwise rotation. For the clockwise rotation, the torque must be taken with the negative sign, and for the anti-clockwise rotation, the torque must be taken with the positive sign. Now again that we see that how the force is affected by the by angle between force, applied force, and the momentum. Over here you can see that this is the force and this is the momentum, and the angle between momentum and force is 90 degree. The torque produced will be 120 into 220 centimeter will be zero point 0.2 meter. If we multiply this, it will be 24 newton meter. Now if the angle is changed, now the angle is changed, the distance in this, you see that turning, the distance is also reduced. The perpendicular distance from the line of action of the force and the axis of rotation reduces to 15. Since the distance moment arm reduces, the force is same, the torque will also reduce. 15 centimeter will be 0.15 meters. So 0.15 into 120 give you 80 Newton meter torque. Now the force is no longer perpendicular, it makes a zero angle with the axis of rotation. You can see that uh, since there is no momentum, so torque will also be 0. 120 into 0 is equal to 0, so torque will also be 0. So these are the three cases we discussed that. So for the maximum torque, the angle will be should be 90 degree. And one more momentum, uh, for you, if you need more torque you need to apply force, and if you need more torque you have to increase the momentum. um, if you are going to open the door from the doorknob, you can easily open the door, but if you are moved towards the hinge and try to open the door, so that will less torque is produced and more force has to be applied. Now how to calculate the do this numericals? Example is a force of 50 newton is applied to a wrench. This is the wrench, and then force applied is 50 newton. This is the line of action of force that is passing from the point where it is applied, is 30, uh, wrench is 30 centimeter long. It means the moment arm is 30 centimeter. Calculate the torque if the force applied perpendicular to the wrench, so the lever arm is 30 centimeter. Okay now. So what is given is that force is given, moment arm is given. You need to apply the formula. The formula is the torque is equal to force into moment arm, and you are going to apply the formula for torque. Torque required is torque. Torque is equal to F into R, 50 into zero point 0.3, that is 15 Newton meter. So these are the simple numericals and simple formula. Now where we find everyday application of the torque, you can see you are turning the key in the lock, you are turning the bottle cap. These are the gears moving in the car or in a grandfather's clock. This is the wrenches turning this bolt nuts, and this is the steering of the wheel. It, there are many example of torque. The movement of the wheel is also an example of the torque. So these are the few daily life example of the torque, and torque is simply the twisting force that tends to cause the rotation. Now you can see that application of more applications of torque, real effects of torque, seesaw or automobile engine. This is, you can see the speedometer, and this there is it is move it is there is a rotation in the needle whenever the force is applied on it. Uh, Turning a steering wheel, seesaws, swinging pendulum, person riding a bicycle, flag flying on a mast. All these are the examples of the daily life example of the torque, and you can see that. So that's it about the what is a talk and how we are going. What are the daily life example of the talk? It is Allah Hafiz, and we will meet again in the next lecture.